Density is an important topic in chemistry and physics, and science in general. A lot of times people understand density strictly in terms of an equation, which you've probably seen before. The equation being density equals mass over volume. But what actually does that mean in terms of different substances? And how can that be applied in a real situation? This video will explain to you what density is trying to tell you. Let's say you have two boxes. They're both exactly the same volume, V1. In the first box, you have feathers. The box is packed full of feathers. In the second box, same size, you've got lead. Obviously, the lead is going to have a much larger mass than the feathers. What happens to the density? Well, if we look at the equation here, we can see that when M gets larger and V stays the same, the quotient is going to get larger. So we would say that the lead has a very large or high density, and the feathers would have a very low density. If we put both of these boxes together into a larger container, obviously the lead would sink to the bottom because it has the higher density. So if you have two substances with the same volume and different masses, the one with the larger mass has the larger density. Now let's look at the second case where we have the same mass but different volumes. So what happens when you have two substances with the same mass? The old joke goes, which weighs more, a kilogram of feathers or a kilogram of lead? And of course the answer is they both weigh the same. But do they have the same density? Of course not. As we saw in the preceding example, lead's always going to sink in a pile of feathers. Why is that? Well, as you can see here, in order to get a kilogram of feathers, I've got to have a lot of feathers. Whereas with the lead, because it's much more tightly packed and each of the atoms is much heavier, it's not going to take up nearly as much space to get that same weight on the balance. So when I look at my density equation here, for the feathers, the volume is large. For the lead, the volume is very small. And what happens to the density when you have a very large denominator? Well, the density gets small. So if we kind of illustrate that, I would put that as a tiny little d. What happens to the density when the denominator gets small? The quotient gets large. And so you can see again here that the density of lead is much larger than the density of feathers, even though they have the same mass.